All right, let's talk about solar energy, because what's happening right now is a full-blown technological revolution. We're moving way beyond just putting a panel on a roof. We're talking about a completely new, self-sustaining ecosystem that generates power, stores it, and, get this, even recycles itself.
You know the image, right? We all have this picture in our heads of those clunky blue solar panels. But honestly, that picture is totally out of date. The solar technology you might be thinking of, well, it's pretty much an antique now.
I mean, the leap forward has been incredible. We've gone from panels that were lucky to convert maybe 10% of the sun's energy into electricity to today's mainstream panels that are hitting 25% or more. And they're not just heavy, rigid blocks anymore. Now they're flexible, they're lightweight, and you can build them into almost anything. It's really a solar renaissance.
So, our first stop on this journey has to be the heart of the whole system, the panel itself. It's being completely reinvented, squeezing out way more power and taking on forms you probably never would have imagined.
You know, the industry has already gone through this massive shift. For years, one type of cell technology was the standard. But now, newer technologies, specifically things called TOPCon and HJT, have totally taken over as the new mainstream. They just give you significantly higher efficiency and better performance right out of the gate.
But if that's today's standard, there's another player on the horizon that's set to completely change the game. It's called perovskite. These materials are not only potentially cheaper to make than silicon, but they are ridiculously good at turning sunlight into electricity.
And here's the really clever part. Scientists aren't trying to replace silicon with it. Instead, they're creating this kind of solar tag team. They lay a super thin film of perovskite on top of a regular silicon cell. Why? Well, the perovskite grabs one part of the light spectrum, and the silicon underneath grabs another. They work together.
And the results are just staggering. We're talking 34.85% efficiency in the lab. Now, this isn't just a tiny improvement. This breakthrough literally shatters the theoretical limit of what a silicon-only cell is physically capable of, a ceiling that's held back solar tech for decades.
So it's not just about efficiency. The actual form of solar is changing in some wild ways. Researchers at MIT have created fabric solar cells so thin and light, I'm talking thinner than a human hair, that you can basically laminate them onto almost any surface. Think about a tent or even a jacket that generates its own power.
And how about solar you can't even see? Seriously, there's transparent solar technology that lets windows generate electricity. It works by capturing the invisible parts of light, like ultraviolet and infrared, while letting all the visible light pass right through. Just imagine, entire skyscrapers becoming vertical power plants and you never even know it.
We're even putting solar panels on water now, and these photovoltaics are a brilliant two-for-one. Not only do they save valuable land space, but the cooling effect from the water actually makes the panels work better, boosting their energy output by up to 15%.
Okay, so we can generate more power from more places in more ways than ever. Fantastic. But now we have to tackle solar's biggest, most classic weakness. How do we keep the lights on when the sun goes down?
This has always been the big but, right? The question that's kind of haunted solar energy's quest to be a primary power source. That whole intermittency problem has been the elephant in the room. But, well, that's changing, and it's changing fast.
The answer, as you might guess, lies in a whole new generation of batteries. But here's the thing. It's not a one-size-fits-all solution. We're seeing different battery chemistries emerge, each one tailored for a specific job. Whether it's the high-density power you need for a car, or the cheap, long-lasting storage you need to back up the entire electrical grid.
The real hot topic right now is solid-state batteries. By swapping out the flammable liquid in today's batteries for a solid material, they can pack in way more energy and they're much, much safer. This is the tech that's expected to give us electric cars that can go, over 1,000 kilometers on a single charge.
And for the grid? Well, this is an absolute game changer. New iron-air batteries can pump out power for over 100 hours straight. That's more than 4 days of nonstop energy. We're not just solving the problem of overnight storage anymore. We're talking about providing power through long, cloudy spells. Total reliability.
Okay, for our final piece of the puzzle, we have to talk about a huge challenge that also happens to be a massive opportunity. What on earth are we going to do with all these solar panels when they get old?
Think about it. That first big wave of solar panels installed back in the early 2000s is starting to reach the end of its life. We are staring down a potential mountain of waste. Projections show it could hit 78 million tons by 2050.
They're calling it the solar tsunami. But what if we stopped looking at this as a waste problem and started seeing it as a resource? Because inside that stream of retired panels are valuable materials. We're talking about a potential $15 billion industry by 2050. That's not a waste stream, that's an urban mine.
So what's actually in there that's so valuable? Well, a panel is mostly glass and aluminum, sure, but it also has that highly refined silicon, copper, and even tiny amounts of silver. And the best part? All of these materials can be recovered at incredibly high rates, over 90% in most cases.
The solution is to build a truly circular solar economy. It's a three-step process. First, the best option is always to reuse or refurbish panels that still have some life left in them. For the ones that are truly done, we use new processes to recover all those high-value materials. And then, this is the crucial step, we feed those raw materials right back into the factories to make brand new solar panels.
So, when you step back and put all these pieces together, the incredible breakthroughs in generation, the new era of storage, and this circular approach to recycling, you don't just have better solar, you have something entirely new. What we're creating is a truly sustainable energy ecosystem. It's a self-perpetuating system. It generates clean power, stores it for whenever we need it, and then it reclaims its own building blocks to build the next generation. It's an energy source that powers itself and then rebuilds itself.
And that really makes you wonder, doesn't it? We're not just talking about some far-off vision for the future of energy anymore. When you see all of these pieces clicking into place right now, you really have to ask yourself, is that future already here?